So our first speaker is Sam Walkow, and she is talking about, oops, I just opened the wrong window, querying data in YT.
Thank you. Hi, everyone. I'm really thrilled to be here. I'm going to talk about querying data in YT, domain stories, and workflows. So to be clear, I'm not actually going to be querying data in YT, but I'm going to talk about some situations where people have. I'm looking for some overlaps there. So I'm Sam. I work with Matt. I'm in the informatics PhD program at the University of Illinois. That's me on the side there. I research data visualization and analysis. And this is a small part of a larger project Matt and I are working on around software sustainability and data. And I feel it's important to mention my background is in psychology and sociology. So I did my undergrad in, and I am not an astronomer or an astrophysicist. I feel the need to mention that when I talk about YT things. So what do I do in this space? I look at different types of software, especially software that has been siloed in different disciplines or laboratories, and physics really fits that bill really well. So I look at people who are addressing a research problem with a specific software and hopefully looking at how those softwares can be expanded. And in particular, I'm interested in reuse of software and repurposing of software. And this is to address struggles scientists have with learning new tools all the time to address their research. And when we pick up a new tool, it can change the way we think about the tool, about the data, and our research process. So part of my work is understanding how tools do that and how we can repurpose tools around that idea. So what Matt and I do together, we're attempting to, instead of redoing the wheel, we're gonna, try and refactor the wheel. And it's part of, like I was talking about, a larger project to understand how people think about data. And as it turns out, physicists think about data in a really interesting way. And this is something I've encountered in my own work with YT as coming from a social scientist background. Data is in rows and columns for me, as opposed to physicists who see it as meshes and arrays and other things like that. So to address software sustainability and different reuse issues, Matt and I are going to attempt to not just understand, but embed how users understand data into YT and use YT as a use case. So what this is going to look like is we're going to build a layer called a domain context framework on top of YT foundations. And yeah, like I said, using YT as a use case. And hoping that, when understanding how users understand data and how a software understands data, it's easier for people to pick up that tool and then ideally jump in as a developer. When that understanding lines up, it's easier for people to do that. So how are we gonna, this is an ambitious project, and Matt and I have talked about a lot of different ways we're gonna come at this angle. And we decided that one of the better ways was to identify common operations that are used in astronomy and then also across other natural science domains like oceanography and weather. What do people use over and over again that's important to everyone's analysis? And this is, again, something I ran into when I was using YT for some medical imaging I was doing. Loading MRIs, it's a little tricky when it loads it in parsecs or doesn't have the color maps I need. So there's some astronomy assumptions that are really baked into YT that we're hoping to kind of not remove, nothing's going away, no functionality is going away, but kind of isolate as we identify some common themes and kind of create a new foundation. So it would kind of be like a reshuffling instead of like a refactoring and trimming of things. And we've identified through the past few years of work 4 groups that we think fundamental operations live in. There's loading and registering data, methods of aggregation, methods of transformation, and methods of plotting. So how are we going to begin to understand users? We decided to start with astronomy. So how are we going to understand how users use YT? We're going to look at narratives. So we're going to sit down and talk to the users and understand their workflow and why they do what they do. So looking at the key steps in analysis. And ideally, we're looking for patterns across users. What do most people do most of the time? And what are their reasons for doing that? And we're also looking for things like common vocabulary. Do people call, certain steps of analysis the same thing? Do they use the same units? Do they use the same fields? Do they call those things by the same names? As it turns out, across natural science, people don't always do that. And ideally, and this is kind of moving beyond the presentation, but this is a longer view of what we have, we would organize this into something the computer could read, that YT could read. And that would be the domain context framework that would live on top of YT. And I'm going to get to that near the end of the presentation. So what are these narratives going to look like? I'm going to organize them using something called domain stories. And this is something I did as part of a class as an investigation into a new kind of data collection to understand how and what YT users do what they do. So it's sort of an interview, but what I had users do, I had 3 people from my lab, doctoral students in astronomy, who are going to remain anonymous. I had them draw their process on a notebook, not a Jupyter notebook, on a paper notebook. I had them draw what they do. This turned out to be a little daunting for some people, but once people started drawing, they did not stop. Interviews went from an hour to 3 hours. People really liked showing me their work. So they're just drawings, and there's some annotation. So some people did pseudocode, some people just wrote in English to kind of annotate their drawing, what they drew, and there's kind of a conversation back and forth between us at the same time. So an interesting part is
Samantha, sorry to interrupt. You have 4.5 minutes left.
Great, thank you.
Thanks.
Okay, then I'm going to skip ahead to the first story. So this is someone that was looking at star formation. And so I know the drawing is a little indistinguishable, but she annotated it with a few different drawings. This was her outcome in YT, and this is how she understood it. And I cleaned up the story. And this looks like a simple few steps in her story, but it's a story about data exploration. So they loaded the file, they took a YT slice of density along the x-axis, then they manually did a time step. They walked through the time step and stitched together a GIF or a GIF using the slice plots. And this seems kind of trivial and small, but it's really interesting because instead of looking at a line graph of density changing over time, they chose to do a slice plot and stitch it together. And I think that's really interesting and suggests a lot about how they understand the data. And they didn't automate the process. They went through and manually looked at the time steps so they could know how far to skip ahead to look at what might next be significant. So it's an interesting meeting of automation and software, and then their own knowledge in their mind and trying to piece it together with the software. Second example is someone looking at moon formation. And theirs was a little more involved, but they did something a little bit similar. They had a similar exploration process. They loaded the data, they took a slice plot of density, this time along the z-axis, and then they created some spatial units. They created a disk and a sphere, and they made a cylinder out of that disk to kind of simulate what was happening with the moon formation. I understand it was a collision of certain things. So they were simulating this spatially. They did the same exploration process, and they used a phase plot at the end to look at some aggregated values, aggregation across temperature, density, velocity, and there was one other that is not coming to mind. So, but they put this all in a for loop, and they said they did this about 200 times. The third example is someone that also looked at star formation. We had to do this over Zoom because the pandemic was taking over at this time, so the drawing looks a little different. They also gave me some results of how they thought about the data when they were processing it in YT. And you can see their story looks similar, but a little different. They chopped it up between exploration and analysis. So they looked at slice plots, density and z-axis again, and this time also a projection plot. And what they were looking for was a possible trend as density changed over time, and also looked at the projection plot to detect if there were any errors in their initial conditions. So they looked at this overall view and then a really specific view. And then they went on to analysis where they also used a phase plot for aggregated values. And this was a particularly interesting case because they talked about how they did the analysis in NumPy and some lower level libraries and how they combined YT and NumPy to do those things. So now we've got these cool stories. What do we do with these cool stories? We want to understand what operations they used and why, and what they were hoping to get out of those operations. And how does the data change as they go from one thing to the next? And in the next steps, I'm going to show you how we're going to organize this narrative into something that can be mapped to a code base and something that will ideally be not just interesting to me, but interesting to software developers. So what are the overlaps in the story? We see exactly the same process for data exploration, which is amazing because I understand in astronomy and astrophysics, you don't get a class on data analysis and how to do this. You kind of pick it up. So it's really fascinating. They all had the same similar story. They look at a slice plot for changes over time, not a line graph, not another kind of visualization. 2 people made movies, stitched them together to make movies. And 2 of the stories had the exact same method for analysis. They took aggregated values, but they also used a phase plot and not any other kind of visualization to understand that. And there's the part outlining the movies to see the change over time in density using a slice plot. So we see a lot of the same plots being used over and over again. And then interestingly, they're used for the same reason. So what does this mean when we map it back to a code base? We are going to construct a JSON schema that's going to be organized using these narratives. And it's going to be a kind of template you can use as a scientist where you can simply fill it in and specify, okay, I want to use YT for astronomy or oceanography, and it's going to help make some useful assumptions for you as you specify your input. So you'll still have all the things you might want in astronomy, for instance. You're not going to lose those functionalities. I should mention this is going to be an independent implementation. This is going to exist outside of YT. This is not something that's going to live in there right away. This will be more of a prototype. And we're going to use what we've identified as common operations to kind of sit at the underlying level. So you can still use useful things like AMR and other functionalities everyone likes to use, but without astronomy assumptions kind of sneaking in there. Future directions, we would love to get stories, not just more stories in astronomy, but more stories of people who don't use YT for astronomy and how you use it and why you use it. We got a lot of useful things out of the drawings from people who had a hard time kind of articulating why they did what they do. And it was really interesting to see people think through it and try and reason with me, not an astronomer, about how they did what they did and why they did it. And it was really interesting. There was definitely some imposter syndrome on the part of the people talking who I think were worried that they were going to do something wrong. And I was going to like run to Matt and tell them that, you know, they used YT wrong. So there was some, and that was really the biggest barrier between getting the narratives. They were worried I was going to like catch them doing something, which was really, really interesting. So I'd love to get more domain stories. If you're interested in sharing how you use YT, I'd love to talk to you. And it's just a simple hour or so where you draw out your process. You can share as much or as little as you want. And ideally, we would start to support domains, you know, geosciences, weather, neuroscience, oceanography, and then continue to support for astronomy. Okay, and that's it. Thank you.
Great. Thanks so much, Sam. That was great. I can clap for everybody because everyone else should stay muted. Awesome. And we do still have time for a question or two if anybody has questions. Yeah. I think, oh, Marikan.
Yeah, hi, Sam. Thank you for the great talk. This was really interesting. So I know you talked about the domain stories of astro people. When do you expect to start interviewing people from other domains to sort of construct those stories? Are you trying to right now just focus on astro? And do you think the prototype will be astro specific? Or do you think, do you kind of plan to include those right in the beginning, some other things like oceanography and stuff?
I'd like to continue to get more stories before we do a kind of prototype. We started with astronomy because that's kind of how YT was already built, and I thought it'd be useful to get an understanding of what we already had before we moved on to another domain. But as soon as we can get IRB sorted out, which I understand is fairly done, we just need to move on to the final stages. I'd love to continue interviewing people over Zoom. I also think we kind of hoped like in person would be possible soon, but it's kind of clear that won't be for a while. And this also happened in the confines of a semester.
Okay.
But I'd love to do several more stories in astronomy, and then also, yeah, in other natural sciences. And I forgot to mention this was from doctoral students like across the spectrum. Some had just started out and other people were getting ready to finish. So it was interesting to get a variety of people at different stages in their career. And I'd like to talk to more people who are in the doctoral phase, but also out of the doctoral phase, because I think that would be an interesting contrast too.
Yeah, that's super cool. How many people would you like ideally if you lived in a perfect world and you got everything you wanted?
I'm trying to think of how much. I would say 20 to 30 people total. More would be awesome, but I think to say like we have something, 20 to 30 people total across all domains, it doesn't have to be 20 to 30 per domain, would be important to have. I think then we could say, we've got something significant.
Okay, cool. Thank you so much.
Yeah.
I'm muted. Okay, now I'm unmuted. We have two really interesting questions in the chat, but we're coming up on 15 minutes. So I'll read them, and then maybe we can move the discussion to Slack, because it seems like these would be really interesting, longer discussions. So from Jill, she asked if you see a big change in storytelling when you did things in person over Zoom versus over Zoom. And then Ricarda asked, have you thought of exploring kind of the difference between early exploration versus final result presentation? And that's often very different. And so both of those are really cool, and I'd love to see more discussions of them on the Slack, because I'm afraid I've got to move on. But thanks so much, Sam. This was really, really
Awesome.
interesting.
Thank you.
I love this.